Welcome Prep 1. Let's study today properties of multiplication in the set of rational numbers. Multiplication operation is always possible in Q as addition operation. First property we have closure. Q is closed under multiplication operation. Commutative property. The product of any two rational numbers doesn't change when we commutating their positions. Associative property. The multiplication operation is associative in Q as it in Z. The multiplicative identity. 1 is the multiplicative identity element, natural element in Q as in Z. Multiplicative inverse. For every rational number a over b not equal 0, there is a multiplicative inverse b over a, where a over b times b over a equal 1. The multiplicative inverse of the rational number is called the reciprocal of the rational number. Note: 0 has no multiplicative inverse because 1 over 0 is meaningless. Remember this. We have another note. The multiplicative inverse of 1 is 1, and the multiplicative inverse of negative 1 is negative 1. Now complete. 7 times equal 1. You want a number times 7 equal 1. It will be 1 over 7. Negative 4 over 11 times equal 1. We have the multiplicative inverse, negative 11 over 4. The multiplicative inverse of negative 5 over 6 is negative 6 over 5. The multiplicative inverse of negative 3 over 5 to the power 0 is, first you can find the value of negative 3 over 5 to the power 0 equal 1, and 1 is the multiplicative inverse of itself. The multiplicative inverse of 0.3 is 0.3 is 3 over 10. Then the multiplicative inverse will be 10 over 3. We have a very important property in multiplying, the distribution property. Multiplication operation distributes over addition and subtraction. If we have a over b, c over d, and e over f belongs to Q, then a over b times c over d plus e over f equal a over b times c over d plus a over b times e over f. Or in subtraction operation, a over b times c over d minus e over f equal a over b times c over d minus a over b times e over f, and the inverse. Let's have an example. State the property of the multiplication of rational numbers used in each of the following statements. Negative 1 over 2 times 2 over 3 equal 2 over 3 times negative 1 over 2. It's commutative, yes. Another one, negative 3 over 7 times negative 7 over 3 equal 1. It's a multiplicative inverse, yes. negative 7 over 20 times 5 over 2 times 4 equal 5 over 2 times 4 times negative 7 over 20. It's commutative. Letter D, 5 over 4 times 1 equal 5 over 4. It's multiplicative identity. 0.8 times 0 equals 0. It's multiplying by 0. Another example, 2 over 3 times negative 4 over 5 equal negative 4 over 5 times, which number is missed? 2 over 3, yes. 2 over 3 and between brackets 2 plus half. We have here multiplying sign, but we didn't write this. We didn't write this sign, but we know this is, yes, distribution. 2 over 3 times 2 plus, we will distribute 2 over 3 times half. 2 over 3 times 3 over 2. Number times the multiplicative inverse, the answer will be 1. Negative 4 over 11 times equal 1. You can divide 1 by negative 4 over 11 to find the answer. It's negative 11 over 4. The rational number which has no multiplicative inverse is, can you remember the important notes? It's 0, because dividing by 0 is meaningless. Find the value of n in each of the following. 5 over 7 times n equal 5 over 7 times number times n equal the number itself. So n equal 1. Negative 7 over 3 times n equals 0. Which number multiplying by negative 7 over 3 equals 0? It's 0. n times half plus negative 3 over 5 equal n times half plus 5 times negative 3 over 5. It will be 5. Which number multiplying by 17 over 3 equal 1? It's a multiplicative inverse of 17 over 3. It will be 3 over 17. Negative 7 over 3 times negative 3 over 7, number times the multiplicative inverse, so n equal 1. Use the properties of distribution of multiplication over addition of rational numbers to calculate each value. 4 over 9 times 11 plus 4 over 9 times 16. In this property, you can find a number common between two numbers. Before plus and next plus. We have 4 over 9. This a common number. And then you can find 11 plus 16. Between two brackets, 11 plus 16 equal 27. 4 over 9 times 27, we can simplify this number. 27 divided by 9 equal 3, and 3 times 4 equal 12. In the second example, negative 3 over 7 times 8 plus 5 times negative 3 over 7 plus negative 3 over 7. You can write beside negative 3 over 7 times 1. So the common number is negative 3 over 7. And we will write between bracket 8 plus 5 plus 1. 8 plus 5 plus 1 equal 14. Simplify 14 with 7. It will be 2 times negative 3 equal negative 6. Another example, 5 over 12 times 3 plus 5 over 12 times 9. The common number 5 over 12. And we have 3 plus 9. 3 plus 9 equal 12. 5 over 12 times 12. Simplify 12 with 12. It will be 5. 18 over 5 times 25 over 9 plus negative 3 over 7 times 25 over 9. The common number is 25 over 9. 18 over 5 plus negative 3 over 7. We can't find same denominators. So you can write in the denominators 5 times 7 equals 35 and the numerator will be 11 after adding. So simplify 35 divided by 5 and 25 divided by 5 equal 5. The answer will be 555 over 63. It will be 8 and 17 over 21. From your booklet, write true or false. The multiplicative inverse of the number 0 over 5 is 5 over 0. Is it true? Can you find the number divided by 0? No, it's false. 0 hasn't a multiplicative inverse. Every rational number has a multiplicative inverse. No, we can find 0 hasn't a multiplicative inverse. Letter C, 3 and 1 over 4 is the multiplicative inverse of 4 over 30. Before answer this, put this number as a rational number, A over B. 3 times 4 plus 1, 13 over 4. Then the multiplicative inverse of 13 over 4 will be 4 over 13. That's true. Letter D, multiplying any rational number by itself, its reciprocal equal the multiplicative identity element 1? Yes, that's true. Every integer is a rational number? Yes, that's true. Put in the denominator 1, it will be A over B, rational number. Letter F, every rational number is an integer. No, not every rational number. 0 is a rational number. Yes, you can write 0 as A over B, 0 over 1, 0 over 2, and so on. Last one, the rational numbers 6 over 15, 8 over 20, and 2 over 5 are represented with the same point on the number line. Put 6 over 15 in simplest form. Divided up and down by 3, it will be 2 over 5. Second number 8 over 20 divided by 4 up and down, it it will be 2 over 5. So all these numbers can represented on the number line by the same point. It's true. Thank you, Prep 1, and goodbye.